Alright, y'all, support 8.6 notes. So they want us to solve equations in this section. So to solve equations, if they got an exponent higher than 1, you want to get everything on one side equal to 0. Well, everything on this one is equal to 0, and they've already factored it for us. So what we got to do is take both of those factors, 11b plus 7, and set it equal to 0, and then set that 4b minus 12 equal to 0. Now, had we not had a 0 here, we'd have been doing different things. So now, solve each of these for those b's. So the first one, you subtract 7. We get 11b equals negative 7. And then we divide both sides by 11. And we get b equals, so that does not reduce. So that's going to be a negative 7 over 11 for my first answer. Second one, we will solve that by adding 12. So 4b equals 12, and then divide both them by that 4, so that gives me my b. Now 12 will divide by 4 and give me a 3. So your two answers are negative 7/11 and 3. Alright, so for my number 2, they're giving me x squared minus 2x minus 35 equals 0. Alright, so let's see what we got. There's no GCF on this. This polynomial is in the right order. So the first thing you want to do is factor that polynomial, because we've already got a 0 on the right side like the first one did. So we just got to factor this and see what goes in here. So the x squared would be the x and the x. That's negative, so one's positive, one's negative. Gotta have unlike signs if that last one's negative. Alright, factors of 35, that'll give me a 2 if you subtract. Let's see, 35, 7 and 5. 7 minus 5 is 2. So since 7 and 5 are your numbers you need, remember the larger number 7 has the same sign as the middle. So the 7 will be negative and the 5 will be positive. Alright, so now you're factored. So now you set both these factors equal to 0. So here you would subtract 5. X equals negative 5. Here you would add 7. And x equals a positive 7. So negative 5 comma 7 is what you want to put in MATLAB and be done. Alright, this one has a 3t squared minus 13t minus 16 equals 0. Now, this one does not have a GCF on it, so to factor it, remember, we got to do 3 times 16. 3 times 16 is 48. So I'm going to make my parentheses. Alright, so what factors of 48 will subtract and give me 13? Well, look at these. These two numbers that I used, 16 and 3, they subtract and get 13. So let's put a t and a t. That's negative, so one's positive, one's negative. Factors of 48 that give me 13 were 16 and 3. 16's bigger, so it's negative like the first number, and the 3 will be positive. Now remember, I got to divide them both by that 3 that I used. Alright, so let's see, bringing down my parentheses. 3 will divide by 3, so that gives me a t plus 1. Over here, 16 don't divide by 3, so we move the 3 to the front, so I get a 3t minus 16. All that equal to 0. And y'all remember, since it's now factored, we set both of these factors equal to 0 and solve them now. So the first one's got one move, we subtract 1, and t equals negative 1. The second one, we got to add 16 first. So 3t equals 16. Then divide by 3. So that t equals, let's see, 16 will not divide by 3 and it will not reduce. So you get a 16 over 3. Look how this answer is opposite in sign than that negative 16/3 was. And then over here you had a 1, and that answer was a negative 1. Alright, number 4, I got 5x squared minus 15 equals 0. So the first thing we want to do on that is factor out that 5. So that's a GCF of a 5. We're going to factor that out. So 5x squared divided by 5 leaves you x squared minus 15 divided by 5 is a 3, and everything's equal to 0. Now, since this 5 got factored out as a GCF, and it does not have a variable with it, we can cancel it out. It's gone. So what we want to do now is take that x squared minus 3 and set it equal to 0. Now, I'm not going to factor that one because there's no way that in factors, because there's no factors of 3 that'll give me a 0, because the only factors of 3 are 3 and 1. So what you got to do is solve this by square roots. So to solve by square roots, you would add 3 to both sides, and you get x squared equals 3. Then you would take the square root of both sides, because remember, that's the way I'm going to get rid of that x squared. Now, if you take the square root of a number out front, you got to put a plus or a minus, and then do your square root of 3. So the square root of x squared is x, and then you get a plus or minus. Y'all, we cannot simplify the square root of 3, so that's just going to stay square root of 3. So you can write the answer in MathLab as a plus or minus square root of 3, or you can do x equals square root of 3, comma, negative square root of 3. Okay, so when we get numbers like this 3 that are not perfect squares, things that I can factor, and all I got is an x squared term, the best thing to do, add 3, and then take square roots. Had that been 3 terms still, an x squared, an x, and a number, and I could not have factored that, then I would have went right into using the quadratic formula. So remember, the quadratic formula could have done this one. A is 1, negative 2, C is negative 35. A is 3, B is negative 13, C is negative 16. It would have given me these answers. A is 5, B is 0 because there's no x term, C is negative 15. Quad would have gave me these two numbers. Alright, y'all, so to finish this out, they're giving us graphs to look at to find our solution sets. So, what we want to do, since this is greater than, and notice, the highest degree is on this side, and it's greater than the side with the lower degrees, which means that the overall graph for our answers will be anything that's greater than this 0 line here. Because what I could do, I could minus 5x and add 14 to both sides, so that this gives me a negative x to the third minus 8x squared minus 5x plus 14 greater than 0, so that any part of this graph here that's above the x-axis is greater than 0. So that would be my solutions. So look, this part that's shaded right here that I'm shading, on the x's, that's coming in from what? Negative infinity. And then it's above the x-axis till I hit this point right here. Well, notice this is going by 2. So 2, 4, 6, 7. That looks like a negative 7. That part's above the x-axis. Union, the other part that's above that x-axis starts right here. Looks like that's what, at negative 2. And then it's above the x-axis till it hits this point. And since these go by 2, that's got to be, what, a 1? And then close parentheses. So the solution, you just got to look at the graph and see what part's above the x-axis, because that's where the 0 line is, okay? Alright, then this last one was the same thing. So notice, it's greater than. So if you move these on the other side, you would have negative x to the third minus 5x squared plus 8x plus 12 greater than 0. Alright, so that was plus 12 greater than 0. So since it's greater than 0, we're looking for the part of our graph again that's above the x-axis. So it's this part right here is coming in from negative infinity again. And it's above until it hits right here. So let's see, that's negative 2, negative 4, negative 6. And then it's going to union this part again that's above. So it looks like this one this time is at negative 1. And then it's above until it hits over here. That looks like 2. And then final answer. So on that, let me pull that down. So on that, once you got everything on one side, it had to be greater than 0. So you're just looking for the parts of the graph that are above 0. And remember, you're looking at what's the x values that this is above. So this is above on the axis until you hit right here. And then the graph is above on the axis while you're going through that part right there. Alright, y'all. Once again, good luck.